Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-4 Extra Practice Solutions on complex fractions. To simplify this complex fraction, we're going to start by finding the LCD of all of these subfractions. So looking at numbers, the only one I have to worry about is this 4. So I've got a 4 in my LCD. And for variables, I have an a. I also have an a squared. So I want the smallest thing that the a and the a squared both go into, and that would be an a squared. So I'm going to multiply all of the subfractions now by 4a squared. So I'll end up doing, when all is said and done, 4a squared over 1 over 4a squared over 1. This way I'm only getting the numerators with this LCD. So I've got 4a squared times the 1 up here, 4a squared times this 4 over a, and 4a squared times the 4 over a squared down in the denominator of the main fraction. Let me go through and cancel out what I can. These 4's here are going to cancel, so that leaves me with a squared times 1, so just a squared. And then over here, the one of these a's from the a squared is going to cancel with this a down here. So I still have an a up here, and then I have 4 times a times 4, giving me 16a, and we're adding that. And then down below I have an a squared canceling with the other a squared, so 4 times 4 is giving me 16 down there. And taking a look at the final outcome here, it looks like I could factor out an a if I wanted to. That would leave me with an a plus 16 inside of parentheses, but I wouldn't be able to cancel anything out as a result of that, so I'm just going to leave things the way they are. On this one, I'm going to start by figuring out the LCD of all these subfractions. That'll help me simplify the whole thing. So for numbers, I've got a 16, and that's the only number in these subdenominators. So 16 goes in my LCD. For the variables, I have an m and an m squared. M squared is the smallest thing that both of these variables go into, so I'll put an m squared into the LCD for that. And then I'm going to multiply all of my subfractions by this LCD. So I'll do 16m squared over 1 over 16m squared over 1. So that means I'm really only multiplying this whole main fraction by 1, but the way in which I'm doing it allows me to put 16m squared with each of these numerators in my subfractions. So I got 16m squared times the 5 over 16, 16m squared times this 5 over m, and then finally 16m squared times the 25 over m squared. Next, I get to go through and cancel some things out. So these 16s are going away. I've got m squared times 5, so 5m squared. Next, we've got one of these m's canceling out with the m in this denominator. So that's 16m times 5. That's going to be 80m, and we're subtracting that. And then finally down here, m squareds are canceling. I've just got 16 times 25, and what's that going to be? Well, that's like having 16 quarters, which would be $4, so that's 400 down there. Now, I am able to factor and reduce a little bit here. My numerator, I can factor a 5 out of both of those, a 5m actually. So that'll leave me with an m minus 16 in there. And then I can't really do anything with the m's, but the 5 and the 400 can reduce. So that's going to be 1 over 80. So when all is said and done, in my numerator, I have m times m minus 16, or I could call this m squared minus 16m, either of those, and the denominator will be 80. For this complex fraction, to get started here, I'm going to find the LCD of all the subfractions. So for numbers, I've got a 16 and a 4. Smallest thing that those both go into is 16, so that goes in my LCD. And then the only other thing I have to worry about is this u squared plus u. There's nothing else quite like it, so I'm just going to make that whole thing part of my LCD. Next, I'm multiplying my LCD by all of these subfractions. So I've got 16 parentheses u squared plus u over 1, and then another one of those down here in the denominator of the main fraction. Doing it like this lets me multiply by 1, but in a way that lets me put my LCD in the numerators of all these subfractions. So I've got 16 u squared plus u times u, and then I have my LCD times the 4 over u squared plus u, and then this LCD here is going to be times the u squared over 4. Going through and canceling what I can, got the 16s canceling, and now I'm just going to distribute this out in case there's any like terms to combine down the road. So this will be u cubed plus u squared Over in my next fraction, the whole u squared plus u cancels out. Good riddance. We have 16 times 4. That's plus a 64. And then down here we have the 16 and the 4 reducing to 4 over 1. So I've got some distributing to do. I've got a 4, I've got a u squared, and I'm multiplying that through here. So 4u squared times u squared is going to be 4u to the 4th. 4u squared times u is going to be 4u to the 3rd. And if I'm thinking about trying to factor this and cancel anything out, because there's no like terms, factoring is really our only play here, I can definitely factor out a 4u cubed from my denominator. That would leave me with a u plus 1. But that's not really going to be all that useful for simplifying anything I could factor out of the numerator. So I'm just going to go ahead and call this one done. For this monstrous complex fraction with 4 subfractions, we're going to start by figuring out the LCD, and then we can simplify things. So for numbers, I've just got a 2. That's it for those denominators. So I've got a 2 in my LCD. For the variables, I have m squareds and m's. The smallest thing that all of those go into is going to be an m squared, which I will proceed to put in my LCD. Now I'm going to multiply all of my subfractions by this LCD. So I'm going to have 2m squared times the 1/2, also times the 2 over m squared, 2m squared times the m plus 3, and then finally 2m squared times the 9 over m squared. Going through and canceling, these 2's are canceling, so m squared times 1 gives me an m squared. And also I've got m squareds canceling in my next fraction up there, so I have a minus 2 times 2, so minus 4. And just kind of thinking ahead, this looks like something I could factor if I wanted to, m plus 2, m minus 2, but I'm not sure I need to. So let's keep going. Down here we have an m. One of these m's from the m squared can cancel this m down here. So distributing this out, we've got 2m squared plus 6m. And then finally over here the m squareds go away, leaving me with a plus 18. So let me see if I can break this down any more. So I know in the numerator that's going to be m plus 2, m minus 2. In the denominator I've got a 2 that I can take out. I'll have an m squared plus 3m plus 9. And if I'm thinking of two things that multiply to 9 and add up to 3, I'm seeing that I can't go any further. Since I can't break this bottom thing down into an m plus 2 or an m minus 2, I don't really need to factor this at all. I can just leave this the way it is and go on to the next thing in my life.